So, good morning. Let's start the oxidation number in the coordination compound, as we have already discussed the few terms in the previous video, like central metal atom, what is the ligands, the type of ligand, what is gelation, so on. So let's discuss the oxidation number of central metal central metal atom. The charge present in on central metal atom in the complex compound is called its oxidation number. Suppose we have a complex compound like this. So if we find out the oxidation, this is the central metal atom, and find out the oxidation number of this particular. Simply we follow the rule जो हम लोग पिछले क्लास में पढ़ चुके हैं कि ऑक्सीडेशन नंबर कैसे फाइंड आउट होता है. वेरी इजी टू फाइंड द ऑक्सीडेशन नंबर बिकॉज इट हैज़ नो एनी चार्ज, सो overall x is equal to +2. In this way you can easily find out the oxidation number of so many complex compound given in your book. Next one, let's discuss the next example. Suppose this is the one. If we find out that if this type of compound is given to you and find out the oxidation of central metal ion. So simply we can find out this will X and the NH3, the ligands which has 0 oxidation number. So simply we can explain by this 4 into 0 minus 2, or X equal to +2. In this way you can simply find out the oxidation number. Few more example. Suppose we have a compound Cl3. So central metal atom, this is the X, and find out the oxidation number of S. We know the ligands NH3 has oxidation number 0, so we can write here it's 6 0 equal to, here is the -3 oxidation number, so -3, and simply you can calculate, so it will come +3. In case of one compound nickel tetracarbonyl, in which the oxidation number of nickel is 0. Oxidation number of nickel is 0, so you can calculate it, and in this way you can try to find out the oxidation number of few of the complex compound. So let's discuss the coordination number. Coordination number. Next terms is the coordination number. So the number of coordinate bond which the ligand forms with the central metal atom, with the central metal atom in that complex compound forms with the center metal atom. In that complex compound is called coordination number. It's coordination number. Suppose we have a complex compound like this, and the oxidation number present on the cation is +2. So what will be the coordination number? 4, because this form 4 coordinate bond with this ligand. Suppose we have FeCN6, so coordination number 6 only. Suppose we have K3 chromium C2O4 and 3. So what will be the coordination number? Coordination number is 6. 3 from here, 3 from here. Coordination number is 3 because this is oxidator has 2 donor sites. So total number of coordinate bond will be 6. So if we EDTA by the number of donor sites, count it and found the coordination number 6. So in this way you can find out the coordination number of particular compound. So next we discuss the how to write the IUPAC name of the complex compound. Means nomenclature of coordination compound. How to write IUPAC name of complex compound. This complex compound. Suppose we have a compound Na4 FeCN6. If we see in aqueous solution, it will dissociate like this 4Na plus and FeCN6 4 minus. So metal present means this is the position of ionization sphere. So at first we write the name of metal present just front of coordination sphere or after the coordination sphere. So at first we like so students find out that this is called the non-complex part. This is called the non-complex part, and this is your complex part. This is your complex part. So the process to write the compound like this, at first we write the name of metal present outer side of coordination sphere. So at first the name of sodium, then after we write the coordination number of particular ligands. So this is 6, so it is called the hexa. Then the name of ligands cyano, and coordination sphere means coordination entirety is anionic part, so that 8, it will end with 8. So the name of central metal atom ferrate. Then after we use the oxidation number in Roman language. In this way you can write the name of so many compound. Next one is suppose the name of NH3 whole 6 and Cl3, and it is your complex part, and it is your non-complex part. So cationic part is complex and anionic part is a non-complex. So how can we write the name of? So at first we start, because here is no any metal atom present outside the coordination sphere, So directly we first write the coordination number. The name of this compound is hexa and hexaamine. So both A stands. Hexa, A stands for this hexa, and amine is both A stands, amine, hexaamine. Then we write the name of central metal, cobalt, and the oxidation number of cobalt come 3. So it should be written in a Roman language in bracket. Then after the coordination, ionization sphere means chloride. So more the number of example is given to you. Next one is, suppose we write the name of suppose number 3. Suppose like this, so many ligands present in the coordination sphere. So how can we write the name of particular compound? So suppose present amine, also present, aqua present, cyano present, and chloride present. So how can we write the name of? So at first we use the alphabetical order. So what will be the name of? And 2 for di, 3 for tri, so on. We use the name of the ligands, or amine, water for aqua, CN, cyano. If chlorine is under the coordination sphere, you see O will be pronounced chloro, so on. So the name of this compound is, at first A stands for amine. So we write here di, 2 for di, diamine, both M here, amine. Diamine, फिर diaqua, then chloro, then cyano, then central metal atom is ferrate, iron, or ferrate, so on, iron. Suppose we use iron also, and the oxidation number then called iron. So in this way you can, this is a complex entity, this is the cationic complex ion. So we use iron. If negative charge present here, so in that case we use 8. The name of central metal atom end with 8. In this way you can write the name of so many. Next one is, suppose given here is CO, E 3 and Cl3, suppose given here. So at first we write the, because here is no metal atom present outer the coordination sphere, so directly we use tris. 3 for this ligand, tris. If 2 here is a base, BIS, base use. 3, so tris. Tris means ethylene diamine, tris, ethylene diamine, then central metal, cobalt, then oxidation number in Roman language, chloride. So tris, this particular 3 number, 2 number, if 2 number is, for 2 number we use base, for 3 number we use tris. Another example is Fe, NH3, 5 and NO2 and Cl2. So what will be the name of this compound? So see here, at first we use penta, amine, both A stands, double M for amine. Nitro, if ONO present, nitro, Then iron, because complex compound is not anion, it is a cation, so iron use this for central metal atom iron, then oxidation number, then chloride. Pentaamine, nitro, iron, then oxidation number, then chloride. So if suppose if we change the ligands like this, Fe, NH3 5 and ONO, suppose we write here like this, ONO and Cl2. In that condition, the name of this compound is pentaamine nitrito, iron 3 chloride. So next one more example is given here. Suppose given here is Cu NH3 whole 4 and SO4. So here is a 4 ligand, so the name of this compound will be tetraamine copper, then name of central metal atom copper, oxidation number 2, then sulfate. So this is for your assignment. Number 1, CO NH3 whole 6 Cl3. Next one is Cu2 Fe CN6, and third one is Ag NH3 whole 2 Cl Cl. Find out the ionic name and oxidation number of central metal atom. So find out the name of this particular, and one more example given to you is number 4, PT platinum NH3 4 platinum Cl, only platinum 4. That's enough for your assignment. Three name of 3 complex compound is given here. Write the ionic name and also find out the oxidation number of central metal atom if present. Obviously present. Now let's discuss about the next topic, that is called the ionization in coordination compound. Sorry, isomerism. Isomerism in coordination compound. Isomerism in coordination compounds. At first we divide into 2 parts. Number 1, structural isomerism and stereo isomerism. This is structural isomerism further divided into 4 parts. This is linkage isomerism, coordination isomerism, ionization isomerism, solvate isomerism, and this is 2 types. geometrical isomerism and optical isomerism. So let's we discuss about the linkage isomerism at first. First, linkage isomerism. This type of isomerism arises due to the presence of an ambidentate ligand in coordination compound. For example, suppose we have CO NH3 5 NO2 Cl2 and CO NH3 5 ONO Cl2. So this type of example is given for linkage isomer. So linkage, one time linkage is from N side, one time linkage from this side. So in this way, another example, Mn CO5 and SCN, suppose, and Mn CO5 and NCS. So this is the example of linkage isomerism. Next one is coordination isomerism. Number 2, coordination isomerism. This type of isomerism arises due to interchange of ligands between the cationic and anionic species. Anionic entities, mostly we can say that, entities of different metal ions present in a complex. Let's we discuss through example. Suppose we have CO NH3 6 and 1 chromium CN6, and only change of central metal ion takes place, chromium with NH3 and cobalt with CN6. So this is the best example. Suppose one example is more for platinum with NH3 and platinum with Cl4, and just change the platinum Cl NH3 3 and platinum Cl3 NH3. So this type of example is coordination type of isomerism. Next one is ionization isomerism. Number 3, ionization. It arises when the counter ion when the counter ion in a ligand in a complex salt is itself a polydentate ligand, itself a potential ligand, not polydentate, itself a potential ligands. Potential ligands which can then become the counter ion, which can then become the counter ion. For example, CO NH3 5 SO4 Br and CO NH3 Br and SO4. One time SO4 out here and one time SO4 is outside here. So simply counter ion in a complex salt is itself a potential in which can then become the counter ion, which can then displaces a ligand and it arises the counter ion. It arises when the counter ion in a complex salt is itself a potential ligand which can displace displace a ligand, which can displace a ligand and then become a counter ion. Displace a ligand and then become the counter ion, which can displace the ligand and become the counter ion simply. And one more example, platinum NH3 4 Cl2 Br2 and platinum NH3 4 Br2 and Cl2. In fact, in this type of ionization isomerism, mainly the exchange of anion within the coordination spheres and the ionization spheres takes place. So simply we can write exchange of anions, within the coordination sphere and the ionization sphere. Within the coordination sphere and ionization sphere. Simply this type of isomerism arises when the exchange of anion in the coordination sphere and the ionization sphere takes place. So next one is the solvent. is the solvent. Solvent isomerism. It's different whether or not solvent molecule is directly bonded to metal atom or merely present. Suppose we have an example. Suppose chromium H2O whole 6 and Cl3 and Cr H2O 5 Cl and Cl2 H2O. And another example is CO NH3 4 H2O Cl Cl2 and CO NH3 4 Cl2 Cl H2O. So simply we can say that it's differ by whether or not a solvent molecule, is directly bonded to metal ion or merely present or merely present as a free solvent molecule in the crystal lattice. If water is the solvent, then this form is solvent, then this form of isomerism is known as hydrate isomerism. So mainly it's differ by the whether or not a solvent molecule is directly bonded to metal atom or merely present as a free solvent molecule in the crystal lattice. So in this way we have completed our structural isomerism. So in the next video we will discuss the optical isomerism. That's enough for today.